Alright, so welcome back. It won't take too long more. We're just going to take a look at a couple more quick examples here and just recap a few other things. So going back to the table of values you did earlier on this lesson, just going to remind ourselves what we're looking for in the tables of values to see if a function is linear, quadratic, or in the case of the new function, looking at exponential. So back in grade 9, you looked a lot at lines and linear functions, and you saw those had constant first differences. In grade 10, you extended that to quadratics, and you saw those had constant second differences. If we add a degree to that and look at a cubic function, well, then we'd be looking at constant third differences. But we're going to see none of that with exponential functions. What we'd be looking for, what we'd see is that all differences have a common ratio, and that ratio will be equal to the base. Okay, so if it was something with a 3 to the x in it, with the base being 3, the common ratio between the differences would be 3. Okay, so one final example here. So I'm going to give you a parent function of f of x equals 6 to the x. And we're just going to find out some information about a transformed version of it. So first things first, I'm telling you that our new equation is going to be y equals negative 3 f of x plus 4 minus 7. We want to find an equation for that. So this takes us all the way back to Unit 1 when we're looking at function notation, transformations here. So we want to figure out what f of x plus 4 is, okay, where f of x is 6x. So we're going to start by figuring that part out first. So if f of x is 6 to the x, f of x plus 4 is just going to be 6 to the x plus 4. Okay, so again, we replaced every x in the equation with x plus 4. That's what that notation is telling us to do. So now that we know this is f of x plus 4, we can replace that in the equation. So we're going to be left with y equals negative 3 times 6 to the x plus 4 minus 7. Okay, and then there's my equation. That's my transformed equation right there. It's got my parent function in there. Okay, so from here I can actually start figuring out my mapping rule. Okay, so in the equation, we're looking at what's happened to x. It's x plus 4. So in our mapping rule, it's going to be x minus 4. Okay, now outside the function, outside my parent function here, I'm multiplying by negative 3. And then I'm subtracting 7, so I'm going to have negative 3y minus 7. Okay. And once we have this equation here, we can actually start creating a sketch. Okay, and that sketch is actually going to help us answer a lot of these types of questions here. So primarily think about domain and range. Now, we know for domain it's an exponential function, so the domain is going to be the xth element of the real numbers. Okay, that part we know, and that'll be true for any exponentials, again, unless there's some sort of real-life restriction on a problem. But for the range, it helps have an idea of what's going on. So we're going to make our own sketch here. We're not going to use Desmos for this. We don't necessarily need it anymore. So I'm going to make a Cartesian plane up here. Okay, and right by looking at this, my transformed equation here, I know where my horizontal asymptote here. I know it's going to be at negative 7. Okay, so I'm just making a sketch here. Not a super detailed graph, just getting an idea of what the shape is. So I'm going to put in y equals negative 7 for my horizontal asymptote. Okay, and to get the general idea of my shape, whether or not I'm increasing, decreasing, whether I'm above or below the asymptote, well, I'm going to start by looking at my parent function. My parent function is 6 to the x. So 6 to the x is increasing, so it has that general shape to it. Okay, if I look at my mapping rule, I have no reflections for the x values. I do have a reflection in the y values. So that reflection here, it's a reflection in the x-axis. So if you want to picture this being reflected down here, now it's going to have a general shape looking like this. Okay, so it's a reflection across the x-axis. We'll have this general shape. You'll notice I'm now decreasing. And you also see with that reflection, I'm now going to be defined below my asymptote. So if I want to make a sketch here, this would be what my graph would look like. My asymptote at y equals negative 7, and a decreasing function that is below the asymptote. Okay, so looking at this, once I have this picture sort of drawn out here, I can see my range relatively easily. I can see right from here that my range is going to be any y value less than, but not equal to, so just strictly less than, negative 7. Okay, so again, having that sketch just ready to access really does help. Okay, now for my y-intercept, I can calculate that by putting in x equals 0 into the equation. Okay, so give this a try on your own as I work through this here. So I'm going to have, if I take my function up here, negative 3, 6 to the 0 plus 4, minus 7. So just simplifying at negative 3 times 6 to the 4 minus 7. You can quickly run that through your calculator to get a y-intercept of negative 3,895. Okay, so it's a very, very large negative y-intercept. I'm going to put that on my graph over here, just going to label it. So you can see that my graph is really, really not to scale, okay, because this distance here is negative 7, and it's this right here is down to negative 3,895. Again, this is just a sketch, just get the general shape. Okay, so is the function increasing or decreasing? You can see from my graph here that it's decreasing. One way I could look at it too, if I didn't have this sketch, my parent function, 6 to the x, it's base bigger than 1, so that's increasing. One reflection would make it decreasing. So this guy's decreasing. Okay, to describe our transformations, again, going back to Unit 1, we're going to look back to our mapping rule here. So if we want to start with the x value, we're going to have a transformation going left 4. Okay, looking at the y values, first thing that happens, we multiply by negative 3, so that does two things. Okay, first thing it does, it's a reflection in the x-axis. Okay, the 3 is a vertical stretch. That's going to be factor 3. And that minus 7 is a vertical translation. So we're just going to say it's going to be going down 7. Okay, so last but not least here, it asks for a sketch, and if you think about it, we've actually already done it. So we did a little sketch up here, and that's really all I'm looking for here. So what I would be looking for in a test or a quiz in terms of a sketch from you guys, you have to make sure you've drawn your horizontal asymptote here. You have to make sure you label your y-intercept, and you have to make sure you get the right shape, whether it's increasing or decreasing, and obviously whether it's above or below the horizontal asymptote. So once you have that, you have a pretty good idea of a sketch. If you want to see what the actual graph looks like, there's a picture here. Okay, so obviously this one's a bit more to scale. It was done with a program. This y-intercept is not shown on here. On our sketch there it actually is. So you can see it's not to scale, but again it gives me an idea of how this graph behaves. Okay, so that's it. There's some practice here, and moving forward we're going to be looking a lot at exponent laws. Alright, see you over there.